Welcome to Manufacturing Processes, Machining and Machine Tools lectures by Professor Joyjeet Ghose. This is the 9th lecture of a series of lectures. This lecture will be on Shaper Machine Part 1. He will be discussing about the components of a shaper machine, specification of a shaper machine, work holding for shaping process, crank and slotted link quick return mechanism, adjustment of length of stroke, adjustment of position of stroke. So, do not miss and watch the full video. For the next video in the lecture series, please click the suggested video link above. You may also click on the playlist at end of the video to access my videos. Please subscribe this channel and yes, do not forget to like and share. Also click on the bell icon to receive instant information of new videos uploaded. Thank you.
Hello friends, welcome to this lecture. In this lecture we will be discussing about shaper machine. Shaper machine is one of the machine tools which is not used industrially a lot because it lacks the accuracy that is required of the industry standards. So let's start with shaper machine. Shaper machine was invented by a person called James Naismith in the year 1836. It was invented much later than slaughter machine. Slaughter machine was invented by Brunel in the year 1800. Shaper machine works in horizontal plane, therefore it is called a horizontal shaper, and a slaughter machine works in a vertical plane, so it is called a vertical shaper. Shaper machine is a machine which is used to produce flat surfaces, and these flat surfaces may be horizontal, it may be vertical, or it may be inclined. Also, shaper machine is used to cut keyways and slots. It handles relatively smaller size workpieces because shaper machine is also a very small machine and it is not a very accurate machine, and therefore it is not a production machine. Now it cuts using a single point cutting tool which is attached to a tool head, and tool head is attached to the ram, and the ram reciprocates over the workpiece. So it cuts linearly in a reciprocating motion. During the forward stroke it cuts, during the return stroke it does not cut, because single point cutting tool can cut during the forward stroke only, and during return stroke the single point cutting tool cannot cut. So therefore, to reduce the loss of time during the return stroke is faster, and this is made possible by using a mechanism called quick return mechanism. Now the quick return mechanism are basically of two types: mechanical quick return mechanism and hydraulic quick return mechanism. Under mechanical quick return mechanism we have Whitworth quick return mechanism and crank and slotted link quick return mechanism. So we will be discussing crank and slotted link quick return mechanism in this lecture, and maybe in the next lecture we will be discussing the hydraulic quick return mechanism. So this is all about shaper, the basic concepts of shaper. And shaper is a relatively simple machine. It is capable of handling small number of workpieces, and one of the advantages of shaper machine is that once the machine is set, it keeps on machining without much of an operator intervention. The operator can set the machine and can do other work. So this is how a shaper machine looks like. This is a brand new shaper machine. You can see the table, the ram, the tool head, the tool, the vise that is fitted. Okay, this is a shaper machine which we have in our lab. We'll discuss the major components of this shaper machine. So first is the base. Base is the component or the part of a machine tool over which the other components are mounted. So naturally, the base of the shaper machine also, it acts as a support for all the other components to be mounted. On the rear side of the base, we mount the column. Column is basically a hollow casting, and the mechanism that is required to drive the ram and the mechanism that is required to feed the work table are housed inside the column. The front face of the column is accurately machined so that the cross slide this cross slide can move up and down, and the top face of the column is also machined accurately so that the RAM can reciprocate. So this is about column. The cross rail is mounted in front face of the column. It can move up and down, and cross rail has a cross feed screw with the help of which we give a cross feed to the table. So during the forward stroke, the tool cuts, and the return stroke, the table moves relative to the cutting tool, so that the new surface is in position with respect to the cutting tool. So the feed is given to the work in case of shaper machine. So this is the saddle. Saddle is mounted on the cross rail, and on the saddle the table is mounted. And you will notice that the table has T-slots on it. These T-slots are used for holding the workpieces directly on the table, or it can be used to fit any kind of work holding devices. Like currently the vice is fitted in the on the table in the T-slots. Now vices can be of various types. You can have a plain vice, you can have a swivel base vice. This is a swivel base vice. You can see the round base about which it can be rotated and fixed at a particular angle. There are other types of vices also which can not only be swiveled, can also be tilted. So that is called, those are called universal vices. You can hold the workpiece directly on the table using T-bolts and clamps. You can hold cylindrical workpieces using V-blocks. You can hold angle plates, the right angle job using angle plates. So various ways of holding the workpiece in shaper, but most common is the using of a vice. The RAM slides on top of the column, which is accurate, which has accurately machined ways. On front face of the RAM, the tool head is fixed on a circular base. Tool head is fixed on a circular base. You can see the tool head. So let's have a quick or a detailed look of the tool head. The tool head consists of a cross slide, and this part is called the apron. The apron consists of the clapper box and the clapper block. There is a radial slide here, slot here, so it can be fixed at any particular angle. This is particularly required when you want to give clearance to the tool in case of vertical machining. And this clapper block is hinged about this pin. So in this clapper block, the tool post is mounted. So what happens during the forward stroke? The clapper block remains fixed during the forward stroke, during the cutting stroke, and during return stroke. See, the tool hits the edge of the workpiece and the clapper block along with the tool post lifts, and this prevents the dragging of the tool on the workpiece. The life of the tool is increased. Also, the surface finish of the work improves. So we have a schematic diagram of a shaper machine. This type of diagrams are useful to draw in exam. You can use this diagram for drawing in the exam. Okay, this is a solid model which I have made using Pro software, solid modeling software. Pro is now called Creo. How do you specify the size of a shaper? The size of a shaper is specified by the maximum length of stroke. Now, what does this maximum length of stroke means? The maximum length of stroke means the maximum length the RAM can travel. That is called the maximum length of stroke. For each of a workpiece, we can set the length of stroke, and the maximum length that the RAM can travel is called the maximum length of stroke. Now, when you specify a shaper by the maximum length of stroke, it not only means that the maximum length of travel of the RAM, but also means the maximum vertical feed, and the maximum cross feed that can be given to the in their particular machine. So normally it ranges from, the size ranges from 175 to 900 mm. This is the standard range. Of course, you can find shaper machine out of this range apart from this range also. Let's say a shaper machine of 200 mm maximum length of stroke. That means that the shaper machine is capable of a maximum length of stroke 200 mm. It is also capable of a cross feed of 200 mm, maximum cross feed of 200 mm, and a maximum vertical feed of 200 mm. Which basically means you can machine a maximum size of a workpiece, which is a cube of 200 by 200 by 200 mm size, or a cube of 200 mm size rather. So this is the minimum criteria that is required to specify a zapper, apart from which you have to specify the power of the motor, the ranges of speed and feed that is available, and the ratio of the cutting stroke time, and the velocity of the cutting stroke and the velocity of the return stroke. The ratio is also very important. Work holding, as I have already said, you can use vices, you can directly mount the workpiece, you can use angle plates, you can use V-blocks, various ways in which you can hold the workpiece. So here, this diagram shows the various ways of holding a workpiece on a shaper machine. This is a plane vise, universal vise, this can be swiveled, and this can be, so not only swiveled, it can be tilted also. This is a T-bolt which is fitted in the table to clamp the workpiece or hold the workpiece. Now let's move on to the mechanisms, the drive mechanisms. So here we will be studying two mechanisms, the crank and slotted link mechanism and the hydraulic mechanism. So let's discuss the crank and slotted link mechanism. Okay, so here in this figure I will first point out the components, then I'll explain the working. So first I'll discuss the construction of the mechanism, then I'll discuss the working of the mechanism. So here we have a pinion 1. This is the pinion 1. The pinion 1 is the driving gear, and it drives the bull gear, it drives the bull gear 14. It drives the bull gear 14. Try to locate the component as I am pointing it out to you. Now the power from the motor is supplied to this gear 1, and it can be changed according to requirement, and accordingly we can change the RPM of the bull gear. So this bull gear rotates as the gear 1 drives the bull gear. In the bull gear there is a radial slide 16. So this is a radial slide here. This is the radial slide. It is fitted to the center of the bull gear. And in this radial slide there is a block 10. There is a block 10. This is radial slide block. This is the radial slide bull gear sliding block. This is called the bull gear sliding block. So in this sliding block, and this sliding block is fitted on a screw 13, on a lead screw 13. So this lead screw is a part of the radial slide. On this lead screw, this is threaded on. This block is threaded on. So this block is threaded on the lead screw. On this threaded block, so this pin, crank pin 11 is fixed. The crank pin 11 is fixed. So 11 is erect on block 10, and on this crank pin we have fit another block. This block is number 12. Number 12 is rocker arm sliding block. Rocker arm sliding block. So this block can slide up and down in the slotted link of the rocker arm. Rocker arm, that is indicated by 9. 9 is the rocker arm or the slotted link. Now this is pivoted at machine frame at 15, and the upper end is fixed to the ram. The upper end is fixed to the ram. So this is the construction. Let's see what happens. Let's see when the gear 1, pinion gear 1 drives the bull gear. So what happens during that time? The crank pin, this crank pin will rotate about the center with a fixed radius. Sorry, please pardon my, this is not a circle, but assume that this is a circle. So it is rotating about a circle with a radius r. It will rotate about a circle with the radius r. Okay, so it will rotate about a radius r, that is this from distance from here to here. Now as it is rotating, this rotates along with this block. Everything rotates. The slide rotates along with the bull gear. The slide rotates along with the bull gear. However, this block number 12, as it is rotating, it is also reciprocating inside the slotted link, and as a result the rotary motion is transferred into reciprocating or rocking motion of this slotted link. The rotary motor of this crank pin is transferred by friction into the reciprocation of the crank, reciprocating motion of this block number 12 in the slotted link, and this as a result it transfers the motion to this, and this rocks about the pivot 15. Now let's see when it moves forward. Let's say during the forward stroke it moves forward. Okay, let's see when it moves forward. So when it moves forward during one half of the cycle, the ram will move as it is rocking in this direction. Let's say it is rocking in this direction. So as it is rocking in this direction, the ram will move forward in a straight line, and at the end the velocity will be 0, and again it will return. So this is how the rotary motion of this crank pin is converted into linear motion of the ram, Now the question is, why it is called a quick return mechanism? Now that is another thing that we have to discuss here. Okay, so we'll discuss that, how it is a quick return mechanism. But before that, how we can change the length of stroke, we'll discuss. So here there is a bevel gear attached to this lead screw 17. Now this bevel gear messes with another bevel gear 18. So 18 is mounted on a shaft which extends outside the machine, and the operator can rotate that particular shaft with a handle. So when that handle rotates, 17 also rotates, 18 rotates, and 18 drives the 17. So when 17 rotates, depending on the direction of rotation of the 17, this lead screw also will rotate, and depending on the direction of the rotation of the lead screw, the sliding block 10 will either move in or move out. So if it moves out in, the length of stroke decreases. If it moves out, the length of stroke increases. So this is how we change the length of stroke. I hope I have a diagram. Yes. So this was the radial slide. You can see here these two bevel gears. So this bevel gear is mounted on a shaft which extends outside, and this can be rotated. This can be rotated by a handle, and when this rotates, and this sliding block number 10 will move in or out depending on the rotation, and therefore the length of stroke can be varied. So this is smaller length of stroke, this is larger length of stroke. Okay, wow, it is a quick return mechanism. Suppose it is traveling from here, this is the forward stroke, and returns here. So angle traveled is this much, whereas the angle traveled in return is this much. Okay, so since the angular velocity is constant, therefore return time will be less because the return velocity will be faster, and the cutting time will be more because the cutting velocity is lesser. And the return stroke, then the cutting time to return time normally varies around 2:1, and the practical limit is around 1.5. So this is the concept here. So I'll show you an animation of this, and you will understand this better. So here you can see here, this is the slotted link sliding block in red. It will move up and down in this slotted link. This is radial slide, this is the cross lead screw, this is the pinion gear, this is the bull gear, and this is the ram, and you can see the velocity here. So the velocity, this is the return velocity, this is the forward stroke velocity. The forward stroke velocity is less, obviously, because it takes more time during the cutting stroke, and it takes less time during the return stroke. So here you can see the velocity, ram velocity graph here. So I'm playing it again. This is a animation which is prepared by this student, two of my students, Priyadasi Siddharth and Ashish Prasad. They have made this animation. So you can see at this position it is returning, this position is returning, and at this position it is returning. So the return stroke is from here to here and the cutting stroke is from here to here. So therefore it is a quick return mechanism. I'll again play this video. You can see it is cutting here, slowly it is moving. Identify the velocity here during the cutting stroke. At this position it will change. So here it changes. Okay, now it's going faster. Just notice this, and you can see the velocity here. Again, you can notice the velocity here. See, it is moving slowly. Velocity is less. Velocity is less. At the end, it will at somewhere around here it will be 0. See, now the velocity is approaching 0, 0, and then again it is increasing, and maximum at the center, and then again decreases to 0, and then again starts like this. So this is the cycle of quick return mechanism. I hope this is now clear to you. So we'll end this lecture here. In the next lecture we'll be discussing the hydraulic drive. Thank you for watching this video.